All right. Hey, is everyone logged in? Okay. All right. We're gonna go through this pretty quick today. We only have a select few proofs I want to do. I said I want to cover more than just the one like we did yesterday. We're gonna jump right into geometry proofs today. So let's see if I have mine out there.
How'd you get a D? George said.
All right. Let's see. Perfect. Okay, this should be appearing on your Nearpod. I'm hoping that comes up.
Yep.
Okay, this one, right? Perfect. Let me zoom in here. I need to make this a little bit bigger so I can use it. Okay, we're going to prove the following. Now, this is our first attempt at this, so we're going to be looking at how to mix algebra with a little bit of geometry and do the proofs and make sure that it makes a logical conclusion. The goal today is before you leave, do you know the basic structure of a geometry proof? Could you attempt to set one up by yourself? Maybe not get it perfect, but attempt to do one. Because I've been showing you kind of the ropes. I did one last week, I did one yesterday. The goal today is to actually get into like the kind of the easier ones, not to do like this crazy, massive, difficult one. But again, if you have not turned in your worksheet 2.6 yet, this one that we did yesterday, and we worked on it every day since last Monday, you don't have the rights to do the shortcuts yet. So that means when we get to the math here, on this problem, you're going to have to do your extra 8 steps, as opposed to my 2. So, because you're going to have to use property of opposites and additive identity, and do the little rabbit hole. Because you have to have this done to prove that you can do it. Okay, so, on this one, we're proving it's not a theorem or anything like that. We're just trying to prove. So on this sentence here, what's the hypothesis? What's the hypothesis on that sentence?
If CD is congruent to EF.
Boom. This part is your given. So when we write our proof, that part has to be given to you. Okay. Now also this we might reserve this for the second or third line. We can use these as well. These are a part of the givens. Because they're on the picture, they are provided. I usually put them in line number 1. Sometimes the book says wait till line number 3 or so to introduce them. They're provided for me, so I'm going to probably write those down right away. Okay, those objects, because they have certain measurements. Okay, the conclusion is this part. This is what you're trying to prove. So at no point in the middle of this proof should you ever use 8. Don't just plug in 8 and try to show that it works. You have to show me the math that gets down to 8 at the very last step. So you're like solving the equation down. Does that make sense? Like what we're doing? Some people like think, oh, they gave me 8, I'm going to use it. That's what you're trying to prove. That's the conclusion. That's what they're trying to get to. Okay? So again, it really comes down to like, do you even know what hypothesis conclusion means? Hypothesis is the part after if, conclusion is the part after the then. That's the part you're given, the part you're proving. So, proof. Let's do that. So here we go. When you do a proof, I'm going to just give you kind of the outline. Line 1 on your proof is usually the given stuff. Now you can just kind of watch this part right now. It's the given stuff. So if you have a bunch of stuff that's given to you, fine, blah, 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 you list it all out. Your reason over here is given. That's literally what you put. It's the stuff they provided you. They gave that to you. It's the given information. Line number 2 of a proof. Line 2 is to like define a vocab term. Define a vocab term, or if they used fancy terminology, like state what that means in terms of an equation. In my case, I think even Jacob Hassler here said it. They said the word congruent, right? You probably should define what that word means, because a lot of people don't even know what that symbol is. So in line 2, you should state that, like that means these things are equal. So it's you're redefining what the word is. And so usually the reason, like off to the side, the reason for step 2, it's the definition of that vocab word, of that term that you're talking about. So like if I'm talking about like certain things are equal, it's because it's the definition of congruent, that they're equal in size, shape, and measure. 3, step 3, is usually trying to get to an actual formula. You want to get to some type of algebra from the stuff they provided you to the vocab term. You want to get to a formula that you can actually use, like an equation, something. Equation. Something where you have two things actually equal to each other that look like algebra 1. And how we do that is usually you substitute to get to there. Now, if you look back to the proof we did yesterday, it was almost exactly that format. Line 1 is a bunch of givens, line 2 is define a word, line 3 was the formula. After that, now I think that one actually took an extra line because we had that transitive property line. But after that, now you're doing all the work, so line 4 through whatever this number takes you to, is you're doing the algebra work. The algebraic, work. That's where you're adding to both sides, you're subtracting, you're dividing, whatever you're doing. Now again, if you haven't done the worksheet yet, worksheet 2.6, that means you have to do every line of work. That means you have to do, I have to add to both sides, I have to do the property of opposites, additive identity, sub, then I can divide to both sides, do reciprocal, multi-identity, and sub. So those are all the properties about solving equations we've done the last couple days in here. So you don't have the right to go to the shortcuts. For everyone else, if you have shortcuts, this might only take you 2 lines of work, and you're done. You get to your answer. Y is an 8. So you can see the differences in why you want to actually work on that. Now, at your last line, wherever that last line is, I don't know what number this is going to be. Okay, question mark, whatever the last line is. You have to put a dot, 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 and it has to get down to what you're trying to prove. On this problem, you better get to y equals 8. That's what your last line should look like. I have no idea what number that is for you. I think for me it's going to be like line number 4 or 5. But you should get down to that, and the reason on this line, wherever this line is, this reason is whatever the math you're doing from here to get to there. That's the reason. So maybe I had to divide to get to that final answer. Fine. It'll be division, the property of equality. It's not a set property name at the very end. It's whatever you did from the line above to get to that line. So that's why it's tough. It's not set in stone what it's going to be. Okay, does that make sense what the outline is? You're going to see this today, no joke. It's going to be the same rules for every problem we do today, like no joke. It's going to have the givens, it's going to probably define a word right off the bat, or like restate something that you didn't quite understand, get to your formula, solve it, get to your final answer. And usually, the problems take about 4 to 5 to 6 lines, somewhere in that range, because usually the givens isn't a lot. Like this one doesn't have a lot of given. We'll kind of modify it so it does. Okay, we ready to go? Let's do the first one, line number 1. Let's do our given information here. Okay, oops, shouldn't write given, what am I doing? Alright, so line number 1, we have to write all the stuff that are provided to us. So we have to start with that first part, the part that followed the word if, the part that Hassler said earlier. CD is congruent to EF. And also, the other things that they did provide me on the picture, what is CD equal to on that picture?
3y minus
3y
9.
minus 9. Okay. And what is EF equal to?
15.
15. All right. They did provide us those things. So that is line number 1. That is all the given stuff. So on the picture, you can see they did give us those numbers. My green arrows point to them. Okay, we good so far? Line 2. We have to probably redefine a word, a vocab word. Well, that's that congruent word we said earlier. Like, what does this congruent actually mean? Congruent means what? Equal to. Equal in size, shape, and measure, right? So I'm going to write CD is equal to EF. I can actually write that they're actually equal. Not just congruent, but they're equal. What this means when I put equal, and notice how the bars, it means if I were to measure this, like with a tape measure, that's equal to the measure of EF, because that's what the congruent says. They're equal in size, shape, and measure. Line 2, that's the definition of congruent. Definition of what congruency means is they're equal. Now, why that's important? this will help me set up my formula. Because now that I know that these two things are supposed to be equal to each other, like common sense, what is CD written up above? What is CD?
3y minus.
Yeah. Now, in line number 3, I can plug that in here. What's EF? 15. Now you can plug it in. Because now I know that those measurements are actually equal to each other, I can get to my set formula. So line number 3, 3y minus 9 has to be equal to the 15. Boom. All we did was we substituted. Substitution. We substituted in things of equal value in for CD, and we substituted something of equal value in for EF. Now, if you're that person that hasn't turned in the worksheet, 2-6, now it's going to take you 8 steps from here to solve. So your proof will be 11 steps. Okay? For me, mine's already done, so now it will only take me 2 more lines to get done, because I can do the shortcuts. So, on this, how do I get rid of the 9?
Add it to the 15.
Yeah, you add it to the other side, right? So by adding it, you can automatically do the work. Notice I wrote down plus 9, but I'm gonna actually do the work. So that's gonna be 3y. The 9s are gone because again we have the shortcuts. We don't have to write 0 and cancel out 0 and then do the other side. We can do it all at once. 15 plus 9, 24. And that was the additive property of equality. Add property of equality. This is the shortcuts that I'm allowing you to use if you have that worksheet done. That you actually added the both sides and it canceled out in a simplified. If you didn't, you'd have to write plus 9. The next line down, you'd have to go 0 on the one side, that's property of opposites. Then you have to cancel out the 0, the additive identity, and then get to the 24. So that'd take you 4 lines from here to get down to the 3y equals 24. So, and again, you'd have to use all those steps we talked about yesterday. Now, but notice, shortcuts make it a lot easier, right? When you do a property equality, you can immediately get to the answer. Just boom, it's 24. We only have one more step. What do we have to do to both sides? Divide by 3, right? That's the property name we're going to do. We're going to divide by 3, so dot, dot, dot. We get y equals, because I divided by 3s. 24 divided by 3 is? 8. That is the division property of equality. Because we divided both sides. We don't need to do all those extra steps unless you haven't finished the worksheet. Because then you're going to have to divide both sides by 3, make the one side a 1 by reciprocal, cancel the 1 using multiplicative identity, and then get to the substitution last, so you'll have those extra lines. So you should be at line 11 by the time you get to y equals 8. But notice I put the dot, 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 because that tells me that's the end of the proof. Do you agree that's the final thing I was trying to prove up there? That's geometry proof. 4 to 5, 6 lines, somewhere in that range. But if you know the structure, you should know line number 1. You should not get line number 1 wrong. You shouldn't get the last line wrong. You know what you're trying to get to. I'm trying to get to y equals 8. So you at least know the start and stop. So really it's just the middle ground. Like line 2 is reserved for definitions, set up a formula, solve it out. That type of thing. They're pretty even keel. Because a lot of these are just algebra problems, as you can tell. We're mixing algebra with geometry stuff. Prove these sticks are equal, that type of thing. Alright, questions at all? Okay, I'm going to try to leave my little explanations up there. I think it's important that you actually see the explanations because we're going to see different problems today. And I want to see if you can try some out by yourself. That's kind of the purpose today. So let's get to another one. Ta-da. Okay. We're not to the one where I want you to try it yet. This is just a different one. Notice there's no pictures on this one. No picture. That's what makes this one more challenging. We have to write a 2-column proof, prove the conjecture. But the steps are roughly the same concepts. This one's a little bit more challenging, so I'll have you try one where we get to back algebra. This one's kind of one of those where we don't have a lot of pictures go off of, so I want you to see this. All right. So we'll get to the proof here in a second. I'm gonna erase all these lines. Let's just talk about what we're given here, what we're trying to prove. We'll see how many lines it will take us. I don't know if it'll take me 5, maybe it'll take me 6. We'll kind of see. Maybe it won't take me that many. Okay, so it looks like we're given a bunch of angles. If, you know, this angle equals this angle equals this angle equals this. We have a bunch of measurements, fine and dandy. Prove that then angle A, the measure of angle A, is 90 degrees. Prove it's 90. Okay, so we know at some point my last line, you know, whatever number it is down the road, you know, you're doing your work, you have your givens, you redefine something, we'll have to do that, set up our formula, and actually do some work. Eventually, we need to get down to the measure of angle A is 90. That's what we're trying to get to. Like that written out exactly that way. So hopefully this will make sense. There's a bunch of different ways to do proofs, so don't feel like there's only one way. There's like a bunch of different structures, but I think this will be pretty straightforward. Okay, what are we given right away? What's our first line? What's the if?
Angle A is congruent to angle B.
Boom.
The measure of angle B equals 2 times the measure of angle C, and then the measure of angle C equals 45.
Measure of angle C equals 45. All right, perfect. Okay, those should be all our givens. Okay, fair enough. We have a lot of given there. We have even some measurements putting in there. That's pretty nice. Okay, ready to go? Line 2. Line 2. Let's redefine that first thing. They talked about the word congruent. What does congruent mean? Equal. So I'm going to say that the measure of angle A is equal to the measure of angle B. And again, the reason why I'm doing that, that is the definition of congruent. It's important that you know what congruent means. It means they're equal. The measurements are equal for A and B. And again, why I'm doing that, that's the first line. I'm redefining what that little symbol meant, that little squiggly sign above the equal sign. Measure of angle A equals the measure of angle B. All right, now, line 3, now we're going to start substituting. We're going to start plugging things in, trying to make a formula, try to go from there. Okay? Because I almost have stuff right now. Because I defined what this thing meant. Well, now I can start to make my formula and try to get down to the final answer where A is equal to 90 degrees. Okay, I don't know if it'll take me 5. Maybe it takes me 6. Maybe it only takes me 4. No idea. Let's try to work through it. But again, does that make sense so far? Okay. Line 3. Let's do this. Line 3. Let's do a quick substitution. What I mean by a substitution, line 3. What was the measure of angle B equal to earlier? 2 times C, right? Do you agree with that?
Mm-hmm.
The measure of angle B is 2 times C. Let's plug that in. So, measure of angle A, and now I'm going to substitute 2 times the measure of angle C in. So on line number 3, I'm doing a quick substitution. I'm trying to set up my formula here. I'm getting there. Does that make sense, like what I plugged in there for angle B? That I plugged in the 2 times angle C? Line 4. Line 4. Let's keep going. We're on a roll now. What is the measure of angle C equal to earlier?
45.
45. Let's plug that in. So, measure of angle A. 2. I'm going to take out this little measure of angle C, and we know that the measure of angle C is 45. So again, I substitute it. Substitution. Because the measure of angle C was 45, so I can plug that in. Last step. What's 2 times 45?
90.
90. Okay, we're done. Dot, dot, dot. Dot, dot, dot. At the very end, this is my last line. The measure of angle A is 90 degrees. Again, substitution. Like, I know that seems weird that we just did substitution 3 times in a row. It doesn't matter. Like, the property names can change. Like, you gotta get used to the properties, right? But a lot of this, we're just taking things that they previously gave us, plugged them in again, plugged them in again. So it was kind of nice. This last one was legitimately substitution, because we're actually multiplying numbers and making up a new number. So it took me 5 lines. Did I know that? No. I had no idea how long it was going to take me. It could have taken me 6, it could have taken me 7. But you can see how they're kind of falling into pieces, how the parts fall. If it was more algebra, where you're actually like solving an equation out, yeah, it might take maybe a little bit more, maybe a little bit less. But you can, hopefully this is starting to make sense. You start with givens, you try to redefine one of the things up there that maybe they say a couple of vocab words. Then you can make your formulas using substitution, then you can do some work going from there. Hard part is when you have to do it yourself. That's the tough part. In fact, let's get to one. Let's try one by ourselves. I think it's important. We gotta try one. Let's try one out by yourself. Here we go. Here's one I'd like you to try today. This is your problem. I want to see if you guys can do it. See if you guys can solve. I gotta back up. Can't even see my picture on the board right now. There you go. There's your problem. It should show up in your Nearpod. I want to see if you guys can do this proof by yourself. Let's see if you're paying attention. I did one very, very similar to this earlier. I think it's your chance to kind of do one in your book. Question? All right, what I'm gonna ask for here in a little bit, I'm gonna ask for volunteers to come up and do just one line at a time. So I'm gonna ask for people to raise their hand. We're gonna go through, you guys saw the problem I did earlier, so this one should look very, very close to that. But I wanna see, can we get like basically the basic structure down, okay? And we'll just do one line. So if you volunteer, you only have that next line that's going up, so hopefully you kind of know it. If you don't feel comfortable, I can double check it before you go up there and give you the thumbs up or yay or nay. But I wanna see, do we at least have the structure down? So anyone wanna volunteer for line number 1? Good choice. Alright, line number 1. I'll trust this one. Boom, very nice, alright. So, 3 givens, very nice. Wrote down the if part, and wrote down what was obvious from the picture. Very nicely done. So anyone, problem number 2. Okay, pick you one. Go up there. Process number 2. This line should hopefully be redefining a vocab word that we had, or something that was obvious from line number 1 that maybe we need to restate. Okay, definition, what do we have off to the side? Definition of congruent, okay, good. I agree with that. The only difference I probably wouldn't have had, I may not have had the little M's on it. It's totally fine. I've actually seen the book do that for yours. They're measuring AB the stick, they're measuring CB the stick, they set them equal to each other. That was good, thank you. Anyone want number 3, where we have to actually come up with a formula? What happened now? No. Okay, we'll skip by actually Wheeler, you did 1, thank you. But alright, Anderson, you're up, sorry, Wheeler, thanks for the volunteer then. Try to get some different people up there. Okay, this one should be where we're setting up a formula now. Nice. Reason?
Yeah, I don't know.
So with an S, it's probably printed on the board still.
Substitute.
Hey, there you go. That's good. You're substituting in parts that you know. Better value. That's very good. Very nice. Way better penmanship than me. Alright. So we want to try number 4. Now we have to actually start solving. 3? You want the first line to work at least? Okay, this is now we're getting down to the hard part. Now we have to, this part is kind of the iffy part, but you guys have done well, so I'm going to trust it. Okay, I agree with that. Okay, so it has a 4x plus, or 4x equals 28. I like additive, property of equality, but you said additive of equality, property of equality. I agree, great, added 6. How do you know to add 6? You are correct though. That's the first step, but why adding 6? It's an opposite, it's an inverse. So they're subtracting 6, you had to add 6 to get rid of it. Okay, that was very, very nice. Okay, number 5, the last step. This one should be one of the easier ones. The last step. How do we get down to our final answer? Alright. Fire away, go up there. Let's see what we have. Thanks for the volunteers. Thank you for all those volunteers that went early. Thank you for that. Very nice, very nice. Division property of equality. Perfect. All right. Very nicely done. Now, all the correct steps. You guys blitzed through that proof really well. Differences I would have had. Okay, we wouldn't necessarily need the M's, not a bad thing though, not a bad thing. The book does have that sometimes when they talk about measurements. I've seen this before, definition of congruent. Sometimes the book writes this and always makes me laugh because they try to abbreviate as fast as they can. Definition of congruent. They actually just write the symbol instead of writing the word congruent. I like the fact you actually wrote out the words. Thank you for those. Later on, I like the fact you actually show the word plus. You can sneeze. I like the fact you actually wrote plus 6, and even the dividing by 4, divided by 4. That's great because you're showing the work. If you didn't have the property worksheet done, there's a lot of steps there. Additive property of equality, property of opposites, additive identity, sub to get the 28, then dividing by 4, that's division property of equality. Getting a 1 is reciprocal, getting rid of the 1 is a multiplicative identity, and then subbing to get the x equals 7. Very nice. One difference here, gotta have property of equality. There we go. That'd be the only difference I would have. So, additive property of equality. But very nicely done. Like that, if I saw that on a test, that's 100%. Like you knew every step, you knew how to set it up, you knew how to, I'm gonna let you know right now, on the test, there's one geometry proof, 1 or 2. I think it's, no, there's 2, there's 2. This is one that you're gonna have to do, for sure. It's that level. It's like 5-1. That's what I'm expecting. I would not expect something more difficult than that, okay? Because I want to test, you know, the basic structure. That's something you need to be comfortable with. Okay, we good so far? Okay, I want to put the next problem on the board. All I want you to do is write it down. We're going to look at it tomorrow. Does that make sense? So it's one of the ones, or I should say Thursday, not tomorrow, but Thursday. Okay, I just think it's important. I'm going to put it up on your, that's the one I want. Okay. And again, you can always make it bigger or smaller, whatever you need to do. Boom. There it is. Okay. I think you hit like command and then the plus or equal sign. Yeah? Okay. Alright, I'm gonna get rid of this. I'm gonna make this bigger just so you can see this. Hopefully it's on your Nearpod in front of you anyway, so you can make it bigger or smaller. I just want you to write this one down. This is one that, it was kind of like, I was trying to think of something like a real life situation where you'd actually have to like figure out what an answer is, not just, you know, not just solving for just a random X, but something real life that actually like makes sense. To me, it's the whole Celsius to Fahrenheit idea. I don't know how to convert that. I always have to like do the formula and solve it. So that was something that I just thought of. So I picked one out of the book that I found that kind of used that. So, so we have to prove on this one, we have to prove that F is equal to 9/5 C plus 32. Now, I'm not going to have you prove this today. We're going to look at this tomorrow, but it is an algebra problem. It's a real life situation where you have to like actually convert one thing to another, but it's a proof. There's actually algebra that's involved in that thing. Okay. Once you have that written down, you're good to go for the day. Make sure your worksheet 2.6 is handed in. The page 130 stuff is turned in. That would be one of our first assignments on this next quarter, other than the, you know, some of the select few things we did last week, because we had a worksheet that we did in class together last week. But yeah, so hopefully that's appearing on your pod. I'm gonna leave that up there. Yes. I got it right here. And I'll take the. Yeah, I have a lunch.
I mean, good on you, Britt.
Yes.
That's so cool.
George, do you